So here are our homework solutions for day 2.8, word problems. So question number 1 here. After ticket sales at a volleyball game, a cash box contains 87 coins in loonies and toonies. If the total value of the money is $161, how many of each kind of coin is there? The situation can be represented by the following system of equations. L plus T equals 87, and L plus 2T equals 161. So obviously in this case, we've decided to declare our variable L for the loonies and T for the toonies. We're told that there's a total of 87 coins. So all the loonies plus all the toonies equals 87. So we simply say L plus T equals 87. Now, we know that loonies are worth $1 and toonies are worth $2. So we take the number of loonies multiplied by 1 plus the number of toonies multiplied by 2 for the $2 that they're worth equals a total of $161. So that's where we get our second equation of L plus 2T equals 161. Now we're asked to solve this by either substitution or elimination. Often, one might even say usually, if something is written in standard form, it can be easier to solve them using elimination. In order to solve using substitution, we need to rewrite our equations in slope-intercept form. And right now our two equations are written in standard form. So since they're in standard form already, I'm going to continue to solve this problem using elimination. So we have L plus T equals 87 and L plus 2T equals 161. The L's for loonies are already matching up. They have the same coefficient and they're both positive. So we can use subtraction to eliminate the loonies. So with that subtraction, L minus L equals 0. T minus 2T equals negative T. 87 minus 161 equals negative 74. So if negative T equals negative 74, then T equals 74. Once we have a value for T, we can sub it back into our equation, either one of the equations, to find out and solve for loonies. So we'll take that 74 and we'll use the first equation. It's the numbers are a little bit easier to work with. Take that 74, L plus 74 equals 87. And when we solve for L, we get a value of 13. So we can say that there were 13 loonies and 74 toonies in the jar. Question 2. A bank teller has a total of 124 bills in 5s and 10s. The total value of the money is $840. The equations represent this situation. And once again, we're given the equations. X plus Y, or the number of 5s and the number of 10s, equals a total of 124 bills. $5 times the number of 5s plus $10 times the number of 10s equals a total value of $840. So there's our two equations. And once again, these two equations are given to us in standard form. And once again, we'll choose to use elimination to solve for this. So to match up the x's, we can multiply the first equation by 5 so that it matches up with the x's in the second equation. So we get 5x plus 5y equals 620. The second equation is already 5x plus 10y equals 840. Both our x's, or x terms, are positive, so we'll use subtraction again to get rid of the x's. 5x minus 5x gives us 0x. We've gotten rid of our x terms. 5y minus 10y equals negative 5y. And 620 minus 840 gives us negative 220. If negative 5y equals negative 220, then y by itself equals negative 220 divided by negative 5, which gives us an answer of 44 for the value of y. Once we have a value for y, we can plug that value into one of the equations. We'll plug it into the first equation, and we'll substitute that 44 in. Gives us x plus 44 equals 124. Solving for x, simplifying, we end up with a value of 80. So that tells us that there's going to be 80 $5 bills. Y is 44. It's already telling us that there's going to be 44 $10 bills. So we have a solution to our equation. The teller has 80 $5 bills and 44 $10 bills. Question 3. At a sale, each DVD is one price and each CD is another price. We're told that 3 DVDs and 2 CDs cost $67. We're also told that 1 DVD and 3 CDs cost $48. This situation could be described by a linear system. 3 DVDs plus 2 CDs equals 67. So 3D plus 2C equals 67. 1 DVD, D, plus 3 CDs, 3C, equals 48. We have our two equations, so we can stack them. Once again, the equations are given to us in standard form, so let's use elimination to simplify this or find the solution. So we've stacked our two equations. 3D plus 2C equals 67. D plus 3C equals 48. It makes sense to multiply the second equation by 3. So we'll take that D plus 3C equals 48. We'll multiply it by 3. And that will give us 3D plus 9C equals 144. Our first equation was already 3D plus 2C equals 67. Our D's match up, and they're both positive. So once again, we will use subtraction to get rid of the D's. 3D minus 3D equals 0D. 2C minus 9C equals negative 7C. 67 minus 144 gives us negative 77. So if negative 7C equals negative 77, then C by itself will equal negative 77 divided by negative 7, giving us a value of 11 for C. Once we have a value for C, we can plug it into either one of the equations up at the top and solve for d. So we'll substitute that 11 for c in equation 2. That'll give us d plus 3 times 11 equals 48. D plus 33 equals 48. D equals 48 minus 33. D equals 15. So in our therefore statement, we can say that a CD costs $11 and a DVD costs $15. An airplane travels at an average speed of 740 kilometers per hour with a tailwind and 560 kilometers an hour with a headwind. This situation can be described by a linear system. So, the speed plus the tailwind equals 740. The speed minus a headwind equals 560. So there's our two equations. Now we have a choice. It would be just as easy to use subtraction to get rid of the s's, or we could use addition to get rid of the w's. In this case, I've decided to get rid of the w's by adding the two equations. So s plus s is 2s. The w's are eliminated because we're adding a positive and a negative together. 740 plus 560 equals 1300. 2s equals 1300. Therefore, s equals 650. So the speed of the aircraft without the effect of wind is the answer to B, and the wind speed is 90 kilometers per hour. That's the difference between the speed and the wind. So if the speed is 650 kilometers an hour, and the speed minus the wind equals 560, we can assume that the difference is 90 kilometers an hour. That's our wind speed.